closing the loop. That's what we're here for today. Okay, so you might not think of the work that you do this way, but we actually work in loops already. This is the work that engineers do. This is work that operations folks do. There's a core development loop and a core production loop. And in MPI and production, we use those loops to actually improve our products, get them ready for launch and announce, and eventually shipment to customers. These will make more sense if I tell you what the loops are. So for development, it's your basic find the issues, figure out root cause, put in corrective action. We do that stuff all the time. Tens, hundreds, thousands of times per program, we run these loops in MPI. In production, there's actually an exact corollary loop. And instead of issues and discovering issues, it's actually about shifts. So what's a shift? You care about if you have more of a failure this hour than last hour, more today than yesterday. That means something's changed on your line, and you want to figure out what it is, because that change could result in downstream effects. So at Instrumental, we use technology to accelerate these loops, and that's what Motorola uses Instrumental to do. So we're going to walk through a very quick case study of how Motorola Mobility uses Instrumental on every single phone they design, and how they optimize their MPI process using our AI system. So if we think back to essentially the optimization kind of elements of optimization, let's talk about how Motorola actually closed several loops in their MPI process and accelerated that with Instrumental. So the first piece of this is collect. So how did we collect? So for our particular implementation of optimization, when we completely collect, we're collecting image data. Probably not a surprise since you saw some stuff in the back there. But essentially, we put a station at key states of assembly down the line. For Motorola, this is generally about 5 to 6 stations, but they have lines with many, many more stations as well. It depends on the product complexity. And generally, for our customers, we're somewhere between 5 is pretty much an average. 3 to 8 stations is generally the range that we put on the line. We're generally putting imaging at places where there's not currently human inspectors, because it would be too many things to inspect for, or vision systems traditionally don't work because there's too many things to look at. And it's not any one of them is high enough ROI to look at it. So that's the data set that we're completely collecting. And then we have kind of 2 use cases in which we were allowed to share. Of course, there's many, but these are 2 we're allowed to share about how they were able to use the rest of that process to actually close the loop. So in this case, Wayne, who's a mechanical engineer at Motorola, was able to essentially use Instrumental data. We identified a defect for him in this area of the PCB. So hopefully you can see from where you're sitting, the PCB board, the FR4 itself, has some problems. Looks like the vias are kind of exploding or something. I don't know exactly what happened, but it's like a process issue. So throw back to your sub-suppliers and getting to keep an eye on your sub-suppliers. So this had gone through a ton of human inspection. It passed all the functional tests, but this actually creates all sorts of concerns and problems because they're going to put these units in their REL tests and they want to validate the design. And if it looks like this going in, seems dicey whether you want to build with those parts or not. So Wayne was able to identify this issue. We presented it in context in the location of where this was happening, and he was able to see this issue because of Instrumental, able to call up the vendor, show them the images of what was going on. They were able to see that they actually still had parts that looked like that in their facility. They figured out it was a chemical change they made in the bath. Problem is solved. It was done within a couple of hours of span. So if you were doing this without having that data, would have taken a lot more time to solve. You may have built units with this. These boards happen to be too thick. If you work in the cell phone industry, Z-stack is everything. Too thick is not something you have room for. So that would have been a downstream problem that they avoided by finding it upstream. Another kind of quick example. So we worked with David, who's a camera engineer, one of our power users. We invited him to be here today. We couldn't make it. To essentially, he's looking at all the different things happening to the cameras on the phone. And one of the things he discovered with the algorithms, essentially the intelligent transformation of this data, is that actually, while the camera's not moving, the trim is moving a lot. And so the cameras look, the concentricity is not good. And you can see it kind of in this GIF, which he made using Instrumental data. And the reason he made this was because he wanted to communicate this in context to his supplier through a language barrier. And so we could actually send the GIF showing the part moving all around. The root cause of this was actually the part did not match the CAD. So they had built the tool wrong. And he was able to find this within the first day of the EBT build, the first build, so before they'd replicated the tools. So it's a big savings for him. He found this issue. They were able to get parts before the end of the build, so they were able to validate, happy ending, and they were able to do so without essentially replicating a tool that had an issue. So in quick summary of like how in general, we're not allowed to share numbers specifically for Motorola, but in general for customers who build with us in NPI, here's kind of how they build out their savings. So usually it's a combination of many factors, but they get value by avoiding things like the tooling issue, which could be quite expensive at the extreme. Reduction in travel, our customers generally travel between 50 to 80% less than they did before they started using Instrumental. So if you're traveling a lot and you don't want to go to Wuhan right now, got it. So we also can reduce DOEs because there's a data record, you can actually do your DOE virtually just based on the data you already have. So you can answer your engineering question without having to build more units. That saves money, especially if you're looking at small error rates where you'd have to build large populations. The main reason that Motorola buys our product is because they've measured that they get better stability and ramp. So they start at a higher product maturity level, and then they're able to ramp quicker. And so the analogy, this is not their numbers, but the analogies to that is like if you're used to starting at 80% yield and spending 12 weeks to get to 96% yield, they like start at 90% yield, and then they can get to 96% yield like much quicker. So that's kind of the stability. And then there's a lot of executive time that is spent on solving these problems. Think about all the exec reviews, the daily mode meetings, all the time that's spent on reporting. You get to avoid all that if you just solve the problems at their root cause. So what about production? So we're actually going to launch something new here today, having to do with maintaining control in the production line. So this is something that we've been offering to our customers for a while, but haven't publicly launched yet. So we're going to launch it right here, right now. So that's about discovering shifts in production. That maintain control is kind of the mantra of production. Because if you have control your inputs, you'll control your process, then you can get good outputs. So we're introducing Instrumental NP, specifically a collection of technologies designed to maintain control in the process, of course built on top of all the other things we do for NPI, specifically for production. And it has kind of three elements to it, which I'm going to show real quickly, and we have a demo in the back. So we do automated line capture. You got to have that for production, speeds it fast. We have a control panel used for maintaining control with live alerts and test coverage heat map. So the combination of these technologies enables us to provide a full service product for production. So automated line capture is an important requested feature from our customers because when you go to production, you need to be able to remove people from the line and still get the data. And it needs to be fast. So this is actually taken from the machine that's in the back. And you can see the registration here is really good. And this is without digital augmentation. So we're able to get consistent images from a moving conveyor without stopping the conveyor. And this is just early days on this, so we're really excited to continue to develop this with customers who are interested in this version of our product. We still have our drop-in stations, but that's the direction we're moving. We can also integrate with your cameras as well. Second piece is control panel with alerts. So if the whole point is to have contextual data that's presented in a useful way, well, this is how I think about production. I want to know what the failure rates are for all the things I'm tracking, and I want to know if those failure rates are concerning levels or not. So you can set up actual live SPC or threshold alerts and get an alert when a particular thing has gone out of band, and you can know. Today, you have to rely on your factory and their MES system and probably at least a 15-minute, if not 30-minute delay, if you even have access to that data in the first place. So here we have much faster real-time data where you can actually find out that you have an issue and where it is. You can click on it, it brings you to this chart. You can click on the chart, it will actually show you the defects, and we have a demo of that in the back. It's great. And then the last thing is when you're setting up hundreds of tests, you need to know where they are. And that was actually a problem we didn't think about in advance. Our customers discovered that one. And so now we're able to actually show in context where all the tests are running on a particular unit, which tests have higher failure rates, where you don't have coverage. And this enables you to quickly identify hotspots. And so it's a nice contextual presentation of information that you can, of course, everything in our app is clickable, so you can click and actually see what's going on in that particular region. And so this is the first time we're actually releasing this and launching this, and we have that demoed in the back as well. So let's talk about, since we've had this product for a little while, and I didn't want to present something without having real numbers for why it's valuable. So I got 3 numbers, and then we're done. So we've been working with several customers across the spectrum on different variety of products in production, and what are the advantages that we get? Well, for one customer, we've actually been able to have crazy amounts of yield improvement for that customer. So high that I didn't even want to put the number here because you wouldn't believe it. But it's over 10 points. So I'm not talking about 10% of some percent. I'm talking about points out of 100, 10 points. That's a lot of percent. This is the whole point of optimization. You can do a lot. There's a lot of low-hanging fruit, and I think that folks don't realize that. And so if you can do that, that's incredibly impactful for a business. And so that's the one proof point. We have another customer, different product, different customer, where they actually have a supply chain limited component. So they're going to get a certain number of something. That's it, certain number, and it's not enough. They don't think it's going to meet their demand. So they want to make sure before they permanently glue that part on that everything else about the unit is great and like not going to fail in some test later on. Because then if it does, they don't get to ship that unit, and there's no display to there's no other part to replace it with. So anyway, that's always the displays anyway. In this case, we're able to actually, it's a top line revenue thing. We're saving them 100 units that they otherwise would not be able to ship because they would have not caught those defects. We catch them in real time on the line. They're able to not put that part on those units, and then they can actually save the parts for the units that are good. And so at this point, we actually read the delta into 100 units a month. And then we worked with another customer where we're saving them primarily on rework. And so we're able to identify issues upstream of where functional tests are, and we're saving them $2,000 a day in rework. So production, lots of opportunity for optimization improvement, and hopefully this time next year we'll have a customer who lets us go public to talk about how they're getting those benefits. But thank you so much for coming today. We have a demo in the back. We've got all sorts of delightful treats. We're going to open this up here. There's going to be a bar. We hope we get to talk to you all, but thank you very much for coming.